the disk is divided into partitions. So each disk or partition, it can be used raw, that means without a file system, or it can be formatted to have a file system. So the entity which contains the file system is known as the volume, and this volume keeps the information about the file system in a device directory or the volume table of contents. So if we look at this is disk 1. It has been divided into partition A and partition B. Each of these partitions, they are considered a volume, and each volume is having a directory. So partition A, which is one volume, is having a directory which is having the information about the file system, and this partition B is again the volume. In this case, you can see that there are two disks and they are in one partition, and so this partition is the volume and it is having the directory information over here. The directory structure is, you can think of as a collection of nodes which contain information about all the files, and both the directory structure and the files, they both reside on the disk. So the directory structure and the files, both of them will be residing on the disk. So what are the operations which are performed on the directory? We can search for a file, that means we can find the entry for a particular file if we are given the file name. So given the file name, the directory can be searched to look for that particular entry of that file. A new file can be created and the information about that file can be added to the directory. Files can be deleted. So if a file is no longer needed, it will be removed from the directory. So this will leave a hole in the directory structure, and then the file system may have to defragment the directory structure to take care of the defragmentation or to take care of the fragmentation or the holes. We can list the directory, that means listing the directory will list all the files and the contents of the directory entry for each file. So each file has a directory entry, so whatever are the contents of the directory entry, that will also come along with the names of the files. Any particular file can be renamed, so the user must be able to change the name when the contents or the use of the file changes. So this facility is provided to the user, and this may also allow its position within the structure of the directory to be changed. Traverse the file system, that means we should be able to access every directory and every file within the directory structure. So the directory can have various forms of structure, and the user should be able to access every directory and every file within the structure of this directory. So the directory is organized logically to obtain efficiency, so that any file that the user is looking for can be located very quickly, and also for naming. This is convenient to users. So two users can have the same name for different files. So like user 1 can call the name of its file can be, let's say, X, and user 2 can also have the same name X but for another file, or a same file can have several different names. So if there is one file, user 1 may like to call it Y1, user 2 may like to call it Y2. So the same file can have several different names, and for different files the users can have same names as well. Grouping, logical grouping of file by properties should also be enabled. That means the user should be able to group the files together, like all programs can be grouped together in one subfolder, all games can be put together in one directory, subdirectory. So this kind of grouping should also be allowed to the users. So there are different schemes for defining the logical structure of a directory. Now we are going to take a look at the different structures of directory. The first and the simplest one is the single level directory. Here all the files for all the users are contained in one same directory. So this is the directory. You can think of the directory as a folder. So here this is the directory, and all the files over here they are contained in this one directory. So all directory entries are here. So this is file cat, so entry for cat is here. This is file bow, so the entry for bow is here. So all the files for all the users are contained in the same directory. This is easy to implement and understand. However, the disadvantages is that when number of files increases, so then it becomes difficult to manage the files in one single directory, and also it becomes difficult when system has multiple users, because if multiple users want to use the same name for different files, then that can be a problem, because within a directory two files cannot have the same name. In different directories they can have the same name. So if two users want to have same name for different files, then this will become a problem in the single level directory. Also grouping will become a problem, because in the directory now no subgroups can be formed, because there is just one level of directory. Now in the two level directory, each user will have his or her own user file directory, or the UFD. So the UFD is the file directory for each single user. So there is one master file directory, which is the MFD, and this master file directory has user 1, user 2, user 3, user 4. Let's say 4 users are using. So all these UFDs, the user file directory, they will have similar structure, and each will list only the files of a single user. So like let's say for user 1, it is having this user file directory. So this is a user file directory for user 1, this is for user 2, this is for user 3, and so on. So when the user logs in, the system's master file directory will be searched, which is the MFD. And this MFD can be indexed by the username or the account number of the user, and each entry will point to the UFD for that user. So whenever the user is using the username or account number, so then the master file directory is indexed. The pointer over there will point to the user file directory, where all entries for the files, so these are the files for this user 1. So this is cat, this is bow. So all pointers to those files are available in the user file directory. So in this way, each user, because they are having their own user file directory, then multiple users can have the same name for different files. Like user 1 is using file name A for this particular file, and user 2 is using the same file name A for this particular file. User 3 can also use the same name, and so on. So then the naming problem is not there. So when the user refers to a particular file, then the UFD or the user file directory of that user is searched. So it is no longer required to search the whole directory as was in the case of the single level directory. So if user 1 is referring to a particular file, then only the UFD of that particular user will be searched. Also, as we just saw, that different users can have files with the same name, and all file names within each UFD are unique. That means within the user file directory of each user, so if this is the UFD of user 1, then file names within a UFD, they have to be unique. They can be repeated in the UFD of other user, but within the same UFD, they have to be unique. To create file for a user, the OS will search only that UFD to check that another file of that name exists or not. If it does not exist, then the OS will create the file for that user. To delete a file, the OS will search the local UFD. That means it will search the UFD of that user who wants to delete a particular file. So this ensures that the user cannot accidentally delete another user's file with the same name. Now user directories here, they are created and deleted as required. So there is a special system program which will run with the username and account information, and it will create a new UFD and add entry for it to MFD. So let's say a user 5 now joins in or logs in and wants to create own files. So now the UFD for that particular user will be created and its entry will be put in the master file directory. So now you will have the UFD of user 5, and if as and when he starts adding or creating files, these entries will come in the UFD of that particular user. So what are the disadvantages of a two-level directory? It isolates one user from another. So in this way, it is advantageous when users are completely independent and do not want to share files, but it becomes a disadvantage when the users, they want to cooperate on some tasks and they want to share files and they want to access one another's file, then this isolation becomes a disadvantage. Also, grouping at user level is not possible. So within this one single UFD, grouping again is not possible because this is a two-level directory. At the first level is MFD, at the second level is UFD. Now this cannot be further created into subdirectories. So the two-level directory can also be considered as a tree of height 2. So the root of the tree is the master file directory and its direct descendants are the user file directories. And the descendants of UFDs are the files, and these can be considered as leaves of the tree. So by specifying the username and the file name, it defines a path entry from the root to a leaf. So if the path has to be defined, so from the root, which is the master file directory, if we want to go to file 1, then this path can be defined. So this becomes the path from the root to the leaf of this particular tree. So every file in the system has a path name. Now, if we think of the two-level directory, we can think of it as a tree of height 2. So now the directory structure, we can also think of organizing it as a tree of any arbitrary height. So this allows the users to create their own subdirectories and to organize or group the files accordingly. So it has a root directory. So this is the root directory, and every file in the system will have a unique path name. So this root directory, it is having certain entries for different directories. So this is at next level, when this is one subdirectory, this is another subdirectory, and so on. This is pointing to this file, and here this subdirectory has again another subdirectory now over here, and each of these is again a subdirectory, and these are the files. So we can form a tree structured directory also. So a directory or a subdirectory, it will contain set of files or subdirectories, and all these directories have same internal format, and one bit in each directory, it will define that whether it is a file or it is a subdirectory. So for a file, it can be specified as 0, or as a subdirectory, it can be specified as 1. So if stat is a file, it can be identified by this bit 0, and if mail is a subdirectory because it is pointing to another subdirectory over here, then it can be specified by a bit 1. Again, over here, prof is a subdirectory again, copy is a subdirectory again because it is having this, PRT is again a subdirectory, EXP, this is a file. So this can be specified by a bit 0. Each process has a current directory. So whenever a process is running, it is using a file, and it is using the file in a particular current directory. And this current directory should be able to contain most of the files which are of interest to the process. So when the reference is made to a file, this current directory is searched. And if the file which is needed is not in the current directory, then the user have to specify a path name, or he has to change the current directory to the directory which is holding that particular file which is needed. To change the directories, the system call takes the directory name as a parameter and uses it to redefine the current directory. In the tree structure directory, path names can be of two types, absolute or relative. In Unix and Linux, absolute path name begins at root. So this starting or this level of directory, this is the root directory and it begins with the initial slash, a forward slash like this, and it follows path down to the specified file giving the directory names on the path. So it will start like this. If this is the case and we want to go to this particular file, then it will be root, then program, then subdirectory E, then subdirectory count. So this will be the absolute path name which will start at the root level. Relative path name defines the path from the current directory. So if we are currently at, say, in this directory, then whatever is the path from this particular current directory, the path will be defined from there. That is the relative path name. So if the current directory is this, that means root spell /mail, then the relative path name is prt/first. So let's see where this is. So if we have spell, root, spell and mail, that means currently we are over here, and then we are going to prt and then we are going to first. That means we are going to this particular file. So this will become the relative path name. But if we want the absolute path name, then we have to start right from the root. So root spell mail prt first. The relative path name will be only prt/first because we are already there in the current directory. So in a tree structured directory, how can we handle the deletion of the directory? So if the directory is empty, then its entry in the directory that contains it can be deleted. So let's say we want to delete this particular directory mail. So if mail was empty, then it can be removed from the directory that contains it. But if it has certain contents, then how can we handle it? If the directory is not empty, but if it contains several files or subdirectories, then two approaches can be followed. The approach one is that the user must delete all files in that directory. And if any subdirectories exist, then the procedure has to be applied recursively to them also. And this can result in a substantial amount of work. So let's say we wanted to delete this particular directory. Now this directory is not empty. That means all the files or subdirectories have to be deleted. So if we look at this particular subdirectory, then we see that it has this subdirectory, it has this subdirectory and this particular file. So all of these will have to be deleted first before this subdirectory can be deleted from here. Once all of this has been deleted, then its entry from the directory which was containing this. So mail was this, all of this was mail. So its entry can be deleted from the directory which was containing mail once all the subdirectories and further files have been deleted. So this is approach one. So this process of deletion has to be applied recursively to all the low level subdirectories. Approach two is that when a request is made to delete a directory, all that directories, files and subdirectories are automatically also deleted. Another way of organizing the directory structure is using a cyclic graph. This allows users to have shared subdirectories and files. The two-level structure or the one-level structure does not allow users to have shared subdirectories and files. Acyclic graph directories allow this. So here the shared directory or the file exists in the file system in two or more places at once. So the entry of that file will exist in two places or multiple places at once. So let's see, if this is one file over here, then its entry is over here also and its entry is over here also. Both of them are pointing to the same file. Similarly, for this particular subdirectory, its entry is over here also. So W is pointing to this subdirectory and words is also pointing to this same subdirectory. So here the shared directory or the file, it will exist in the file system in two or more places at once. Though the entry for that file or subdirectory is existing in two or more places, but it is not two copies of the file. It is the same file or same subdirectory. Like for this example, it is one file only, though its entry is at two places. So there is only one actual file which is existing. So any changes which are made by one person, so if this person is making any change to this file, then these changes will be visible to this person as well immediately. Similarly, this subdirectory, it is the same copy, though it is having like entry in multiple places in the directory structure. How can we implement these shared files and subdirectories? One approach is to create a new directory entry called a link. So suppose if initially this was not there, only this file had an entry over here in this subdirectory. Now if another user also wants to share this file, then how it can be implemented? By creating a new directory entry which is called a link. That means this entry that will be created, it will be referred to as a link, and this link is just a pointer to another file or subdirectory. That means this file is already existing, file or subdirectory is already existing, and this is just a pointer now, and it can be implemented as an absolute or a relative path name. So when any reference to the file is made, the directory is searched, and if the directory entry is marked as a link, so now this has been marked as a link over here, so then that link is searched and the name of the real file is found from the link information, and this link can be resolved by using that path to go and locate the real file. And this link is clearly different from the original directory entry. The original directory entry was this, the link. So this is having some extra information, and this link is different from this original directory entry over here. Approach 2 is that we duplicate all the information in both sharing directories. That means whatever information was there in this entry over here, the same information is kept in this directory as well. So this is duplication of information in both the sharing directories. Both the entries will be identical and equal. So these duplicate directory entries make the original and the copy indistinguishable, which might cause problems if the file is updated. So what are the problems in acyclic graph directories? The problems are that the files may have multiple absolute path names. So if we talk about this file, its absolute path name is / which is the root, dict, then count, and it can also have /spell /count. So it can have multiple path names over here, and the distinct file names, they are referring actually to the same file. Also, how to take care of the deletion? If the space which is allocated to the shared file, how can it be deallocated and reused? So approach 1 is to remove the file whenever anyone deletes it. So if any the users who are sharing it, if anyone wants to remove the file, then delete that file. But now what will happen is that there will be some dangling pointers to a non-existent file. Suppose this user over here wants to delete this file. So this user has deleted the file and this file is no longer existing, but this pointer is already there in the other subdirectory, which is now pointing nowhere. So it is pointing to some file which is now not existing. So if these remaining file pointers, if they contain actual disk addresses and the space which is this disk address is now, suppose if it is used for some other file, then this dangling pointer will actually be pointing to some other file. Approach 2 is that we preserve the file until all references to it are deleted. That means all the users, all the subdirectories which are referring to that particular file, once all wish to delete that file, till that time the file is preserved. Once all references are deleted, then the file is deleted. That means there has to be some mechanism or count to be maintained to determine that last reference to the file has been deleted. So this was in brief about the directory structures.